quadratic equations. In this lecture, we are going to learn how to find the range of given expressions. So in previous lecture, we learned how to find the range of fractional rational functions which are in the form of a linear by linear, linear by quadratic, or quadratic by linear, or quadratic expression by quadratic expression. So how we find it there? First, we considered the given expression. Okay, from the above, if the question is given any one form of the above, the given expression is some y. Okay, then after that, the given expression is some y. Then after that, so we need to check for the numerator and denominator whether they are having a common factor or not. So first thing, do not have a common factor. Okay, those the numerator and denominator do not have any common factor. Next, we need to express by cross multiplying, we need to express the given expression in quadratic expression, okay, as a quadratic expression in variable x. Okay, in variable x. So, and as x is real, we need to check for discriminant is greater than or equals to 0. The solution of this discriminant greater than or equals to 0, this inequality is our required range. Okay, let me understand again with one example. Here the question is given that x plus 2 by 2x squared plus 3x plus 6. Okay, so the first thing we need to assume, let y equals to the given expression which is in the form of linear by quadratic. Then these do not have any common factor. Let's simply cross multiply. Then what we obtain, 2y times of x squared plus 3y times of x plus 6 into y, 6y equals to x plus 2. So we can write this is as 2y minus 1. Sorry, no. Okay, simply it is a x square is 1 itself. So 2y times of x square, 2y times of x square plus 3y minus 1 into x. Why? Because this x is moving LHS side, and we can write this is as 6y minus 2 equals to 0. We expressed this as a quadratic equation in terms of variable x. Okay, next we need to check for x is real. We need to check for the discriminant is greater than or equals to 0. Now discriminant greater than or equals to 0 means b square minus 4ac is greater than or equals to 0. Here what is b is nothing but 3y minus 1 whole square minus 4 into a is 2y, and 6y minus 2 is greater than or equals to 0. Okay, if we simplify this, what will obtain? 9y square plus 1 minus 6y, and 8y into 6y minus 48y square minus into minus plus 8y into 2, 16y is greater than or equals to 0. What will obtain over here? 9 minus 48 means minus 39 y square, and plus 10y plus 1 greater than or equals to 0. If we take minus as a common, then we can write this is as 39y square minus 10y minus 1 is greater than or equals to 0, and that implies, so any inequality, now multiply with minus 1 on the both sides. If any inequality is multiplied by a negative sign, then the inequality changes. Greater than or equals to will become less than or equals to. Then we can write this is a 39y square minus 10y minus 1 is less than or equals to 0. So from this one, the expression must be less than or equals to 0. But here what he has given, the coefficient of x square, that means a, generally we consider it as a equals to 39, which is greater than 0 and is positive, but the expression must be negative. So coefficient of the x square and the expression are in opposite sign. Just recall the concept of, okay, just recall the concept of sign of quadratic expressions in that one. So now, okay, in that one we discussed that ax square plus bx plus c equals to 0 function having the roots as alpha and beta. Okay, then we obtain the two conditions. So alpha less than x less than beta. Okay, in this range, the expression and the coefficient of x square will have opposite sign. Okay, these two have opposite sign. Okay, next, what is the another condition? If x less than alpha or x greater than beta, the expression ax square plus bx plus c and coefficient of x square have the same sign. Okay, have the same sign. Now this is the concept. Okay, now can we express the given expression in terms of the factors alpha and beta? Can we write this as, okay, right, the expression we are getting, it is a 39y square minus 10y minus 1 less than or equals to 0. So what we can write, this is a 39, product is minus 39 and addition is minus 10, when we can write as minus 13y plus 3y minus 1 less than or equals to 0. And we can express this is as a factors is 13y plus 1. Okay, 13y plus 1 into 3y minus 1. Okay, into 3y minus 1 less than or equals to 0. So that means here we obtain the values of y equals to minus 1 by 13 and another value of y is 1 by 3. Okay, so that means which is in the form of it, the expression is having the two roots alpha and beta, where let I am considering alpha is 1 by 13 which is less than or equals to our consideration beta is 1 by 3, then alpha is less than beta is satisfied. And what is here, over here we are obtaining the coefficient of x square is positive. Okay, but the expression is negative. So these two are having opposite sign. When these two are having the opposite sign, if minus 1 by 13 less than, but in the expression that means inequality we are obtaining less than or equals to, less than or equals to x less than or equals to 1 by 3, then what it is, 39y square minus 10y minus 1 and a equals to 39, which is a negative and which is positive. Now in this range these are having the opposite signs. Now what is the range of given expression? We can write it as y belongs to minus 1 by 13 comma 1 by 3. That means the range lies between minus 1 by 13 to 1 by 3. Prove that 1 by 3x plus 1, 1 by x plus 1 minus 1 by 3x plus 1 x plus 1 does not lie in between 1 and 4 where x is a real. Okay, so how to solve this? Consider the given expression as y which is equals to 1 by 3x plus 1 plus 1 by x plus 1 minus 1 by 3x plus 1 into x plus 1. Okay, so now make the LCM. What is the LCM we obtain over here? 3x plus 1 into x plus 1, and here we obtain x plus 1 plus for x plus 1 we write it as 3x plus 1 minus, it is having the same, then it is minus 1, then y equals to 4x plus 1 by 3x plus 1 into x plus 1, which can be written as 3x square plus 3x plus x 4x plus 1. Okay, now which in the form of linear by quadratic. Now cross multiply. Okay, asking for the range that does not lie in between 1 by 4. He is asking us to show that now the given expression does not lie in between 1 and 4, means if we find the range, then we can say that whether it is lies in between or not. Okay, so now we can write this is a 3y times of x square plus 4y into x plus y equals to 4x plus 1. So which can be written as 3y times of x square, and take all terms into one side, 4y minus 4 into x plus y minus 1 equals to 0. Now we expressed as a quadratic expression in variable x, where x is a real, given that x is real, the values of x are real only when the discriminant is greater than or equals to 0. Now find out the discriminant greater than or equals to 0. If the discriminant greater than or equals to 0, 4ac minus b square. So b square minus 4ac greater than or equals to 0. That means b square means 4y minus 4 whole square minus 4 into 3y into y minus 1 is greater than or equals to 0. So if we simplify this, what we can get it as 16y square plus 16 minus 32y minus 12y square plus 12y is greater than or equals to 0. Now we can write this as 16 minus 12y square means 4y square. Next minus 32 plus 12 means minus 20y. Okay, minus 20y plus 16 is greater than or equals to 0. Okay, now okay, first of all we need to find out whether this can be expressed as factors or not. So we can write this is as how we can write this as y. If we take 4 as a common, y square minus 5y plus 4 is greater than or equals to 0. Okay, we can write this as y square minus 4y minus y plus 4 is greater than or equals to 0. So now we can express this as a factors of y minus 1 into y minus 4 is greater than or equals to 0. Okay, right. So greater than or equals to 0. What it is? So we obtained as let alpha equals to 1 and beta equals to 4. We had just discussed that what it is, ax square plus bx plus c having alpha and beta are the roots. Then if x less than what is alpha less than x less than beta. Okay, so where the expression and the coefficient of x square, okay, and the coefficient of x square will have opposite sign. Okay, will have opposite sign, but for x less than alpha and for x greater than beta, or for x greater than beta, the expression and the coefficient of x square will have the same sign. Okay, if it is positive and the expression is also positive, and here the coefficient of x square, from this one, what is a equals to 1, which is greater than 0, that means positive. So here a is positive and asking us to show the expression is also positive. So we need to check for both having the same sign. When this will be have the same sign, y less than, okay, here equals to ganaka, so y less than or equals to 1 or y greater than or equals to 4. Now we will get the y square minus 5y plus 4 greater than or equals to 0. Okay, so what is the range? Our required range is y less than or equals to 1 or y greater than or equals to 4 is our range. Okay, so that means in a linear scale, if we consider over here it is as a 1 and over here it is as a 4. Now what is our range? Some minus infinity to plus infinity. So our range is the same thing can be written as minus infinity comma 1. Okay, 1 is our range and union 4 to infinity we can write in this manner. So minus infinity to 1, okay, is our range, and 4 to infinity is also our range. Now it is not lying in between 1 to 4. Okay, 1 to 4 it is not lying. So what is asking us to show? He is asking us to show the given expression. Okay, the given expression not lies in between 1 and 4, and just we showed that it is not lying in between 1 and 4. It is lying less than 1 and it is lying greater than 4, but in between it is not lying. So which is our required range, and we showed that the given what is question is having not lying between 1 to 4. If expression x minus p by x square minus 3x plus 2 takes all real values. Okay, what he is giving, this expression x minus p by x square minus 3x plus 2 takes all real values. When the values are real, so discriminant is greater than or equals to 0. For x also real, for x also real. So when we obtain the real values of x, whatever the equation in terms of x, quadratic equation in terms of x, discriminant greater than or equals to 0, we obtain x is real. and this expression is also real. He's saying that expression is also real means whatever this expression is also having the root size greater than or equals to 0. Okay, discriminant is greater than or equals to 0. Then find the bounds for P. Okay, asking us to find the range of P. Okay, right. So first thing what we need to consider, let the given expression equals to y, that is equals to x minus p by x square minus 3x plus 2. Now what is express this as a quadratic equation in terms of variable x. Simply what we obtain, y x square minus 3y into x plus 2y, which equals to x minus p. Okay, so now as a quadratic equation of x, we can write this is as y x square minus 3y minus x, okay, minus 3yx and minus x plus 2y minus p equals to 0, and y x square minus of 3y plus 1 into x, okay, minus of 3y plus 1 into x plus 2y minus p equals to 0. Now which is as a quadratic equation in variable x. So x is real, he has given that. That means we need to check for discriminant is greater than or equals to 0. So discriminant is greater than or equals to 0 means minus of 3y plus 1, okay, minus of 3y plus 1 whole square minus 4ac, which is nothing but 2y minus p is greater than or equals to 0. And if we simplify this, we obtain this is as 9y square plus 6y plus 1 minus 8y square minus into minus plus 4py greater than or equals to 0. Okay, that means we can write this is as y square, okay, y square plus, and what will have minus into minus plus, minus into minus plus, and a small change over here, just make the changes is, so what it is x minus p. If we move into the LHS side, here we'll get it as a plus p. Okay, here we get it as a plus p, and what it is minus, and over here we obtain this is as a minus. Okay, just change here. Okay, so it is minus p LHS to the plus p, and okay, right, we are doing over here 9y square plus what we obtain 6 minus 4p into y, okay, 6 minus 4p into y plus 1 is greater than or equals to 0. That means again we are getting the discriminant in terms of variable, what is quadratic equation, and which is greater than or equals to 0. Now solve for this one, what we are obtaining. So the roots are obtaining it is as y square plus 6 minus 4p into y plus 1 is greater than or equals to 0. And how to find out this? So this what it is, okay, ax square plus bx plus c is greater than or equals to 0. In the graph of a quadratic equation, we have seen that when in the quadrants it is greater than or equals to 0, okay, the expression is equals to 0 and greater than, okay, expression is greater than or equals to 0. Either if it is greater than, the curve is in the form of like this. Okay, if it is what it is a greater than 0 and discriminant is less than 0, we obtain this, and a greater than 0 and the discriminant is equals to 0, we obtain this condition. Okay, so that means here the p value is not known to us, but it must be greater than or equals to 0. If we consider this expression is having the roots means it is some between some values it is negative. Okay, for between the values for alpha and beta it is negative, but it is clear that y square plus 6 minus 4p into y plus 1 is greater than or equals to 0. So that means it is above the x-axis. Okay, so it is above the x-axis or it touches the x-axis, but it does not intersect the x-axis. So from this one we can say that this expression is, for this one, the y square plus 6 times of 4p minus y plus 1 is having the discriminant less than or equals to 0. Then only we obtain this y square plus 6 times 6 minus 4p of y plus 1 is greater than or equals to 0. So that means now we need to check for the discriminant. For this one, the discriminant is less than or equals to 0. Then how we obtain 6 minus 4p whole square minus b square minus 4. A is 1 and c is also 1, the less than or equals to 0. Okay, so if we simplify this, what we obtain over here, I think you understand the concept why we have taken discriminant is less than 0 for this one. Okay, here the p is unknown. If the p is known, we can factorize or we can identify the roots of the nature, but here the p is unknown, we need to find out the p. So to find out the p, now we have seen the graph of the quadratic expressions. So a is greater than 0. Why? Because the coefficient of x square is 1, which is greater than 0. We have the three graphs for a greater than 0. One is the discriminant is less than or equals to 0. The roots are complex, it is above, greater than, the expression is above the x-axis, and if the discriminants are equals to 0, the expression is above x-axis and touches the x-axis. But if the discriminant is greater than 0, what happens over here? It has to intersect the x-axis, and for some values the expression is negative. But here clearly mentioned that the expression is always greater than or equals to 0. Only these two conditions satisfies. As a greater than 0, the discriminant is equals to 0 or less than 0, then we are considered discriminant is less than or equals to 0. Okay, now if we take 2 as a common from this one. Okay, if we take 2 as a common, what it is? 2 into 3 minus 2p, and 2 square means 4 into 3 minus 2p whole square minus 4 less than or equals to 0. Okay, if we take 4 as a common, what we obtain it is as 3 minus 2p whole square minus 1 less than or equals to 0. Then we can write this is as in the form of what is 9 plus 4p square to 4 minus 12p minus 1 less than or equals to 0. Then we can obtain this is as 4p square minus 12p plus 8 less than or equals to 0. And again if we take 4 as a common, then we can write as p square minus 3p plus 2 less than or equals to 0. Then we can factorize this is as what it is, p minus 1 into p minus 2. Okay, p minus 1 into p minus 2 less than or equals to 0. Okay, it takes all real values. Okay, it takes all real values, and we can express this is as 1 less than or equals to p less than or equals to 2. Okay, so 1 and p, that means p belongs to 1 comma 2. Okay, 1 to 2. Okay, that means here 1 and 2 are also included, but the expression if p is equals to 1, okay, if p is equals to 1, what we can obtain over here? If p is equals to 1, the expression we obtain is equals to x minus 1 by x square minus 3x plus 2. Okay, x square minus 3x plus 2 is nothing but, so we obtain x minus 1 by, and what it is, x minus 1 into x minus 2. So here these are having the common factor, that means x not equals to 1. So that means if x is equals to 1, if p is equals to 1, these are having the common factors at x not equals to 1. So the p equals to 1 is not in our solution. Similarly, if p is equals to 2, we get the expression as x minus p by x minus 1 into x minus 2. Again the x not equals to 2. Why? Because x minus 2 is a common factor. So finally we can write this is as, okay, the p, even though we are getting 1 less than or equals to p less than or equals to 2, but for p is equals to 1 and for p is equals to 2, so the given expression is not defined. If we substitute p is equals to 1 and p is equals to 2, the given expression is not defined. The expression is defined only when x not equals to 1 and x not equals to 2. And finally we can say that, so the equality is removed. Why? Because if p is equals to 1, p is equals to 2, the given expression is not defined. Then we can write the bounds for the p as 1 less than p less than 2. Okay, it lies, the p values lies in between 1 and 2 but the p does not include 1 and 2. Okay, 1 and 2 are not included. So in between values 1 less than p less than 2 are defined. I think you understand how to find out the range of the given expressions.